Chapter 5.3 Factoring Trinomials. To factor a trinomial of a form ax squared plus bx plus c, where a is 1, look for two integers with a sum of b and a product of c. If a isn't equal to 1, then the first step to take is to determine if we can remove a common factor first. But we're going to go over the simple case first, where a equals 1. We'll come back to that later. Example 1. Factor x squared plus 5x plus 4 using algebra tiles. In 5.1 video, we talked about how to find the product of two binomials by using algebra tiles. And back then, we were given two expressions to multiply. This time, we're given the product. We're given the area of the rectangle. Because this is an area of a rectangle, we need to find the length and the width. Normally, we say A equals length times width when we're looking for area of a rectangle. And we are given the area. So area is x squared, and there are 5 x's, and there's positive 1 bars here. So the area equals x squared plus 5x plus 4. So we know this is a product of two binomials. So in order for us to reverse the step and find what length and widths are, we need to draw the corresponding bars on the top horizontally and vertically. Next step would be to find what these bars, horizontal bars, represent. We have one x bar, so x, plus there's 1, 1, 1, 1. So there's positive 4 bars. How about here? This is a positive x bar, and this is positive 1 bar. We have x plus 1 vertically. So length was x plus 4, and the width equals x plus 1. If we were to write this in an equation, we'll have to state that x squared plus 5x plus 4 equals x plus 4 times x plus 1. Let's take a look at method number 2. We need to find two integers that can add to b and multiple to c. So let's take a look at what that b and c represent. I talked about how in order for us to factor a trinomial in that form, where a equals to 1, we need to look for two integers with the sum of b and product of c. So I'm just going to write that form down here. So we have ax squared plus bx plus c, and our expression is x squared plus 5x plus 4. So you can see that our b is 5 and c is 4. So we need to find two integers that can add to 5 and then multiply to c, which is 4. So let's think about what are the factors of 4. You can guess and check from here, or you can just start with figuring out the factors of 4. So factors of 4 would be 1, 2, and 4. So in order for us to get 4, we can say 1 times 4 equals 4, but also 2 times 2 equals 4. Okay, so either is 1 and 4 pair or 2 and 2 pair. Let's say I picked 2 times 2 equals 4. We can double check if it's correct by putting the factor of a, which is always 1 in our simple case. So factor of a, we're going to look at cases where a equal to 1 only for now. And then we have, secondly, factor of c, factors of c. So let's put 2 times 2, like that. So next step would be cross multiplying and adding. So cross multiply, then add. All right, so let's do 1 times 2, 1 times 2 right here, and then we are going to add another 1 times 2. We get 2 plus 2, which is 4. And this value here must equal to 5. But it's not. It's not equal to 5. So this is incorrect. Our guess is wrong. Let's try once more. We only have the second pair available here, so we'll use this one now. All right, so we have 1 by 1 for factor of a, and then we have 1 and 4. We're going to cross multiply and add. So we get 1 times 4 plus 1 times 1, which equals to 4 plus 1, and that equals to 5. And this value corresponds to this one over here. So our factors are correct. Once we find out that this value equals the middle term, b, then we need to put the brackets around horizontally for the first row and another one for the second row. And then rewrite this using the variable. We have x squared, that's essentially timesing x times x. So we have to write x and another x. We will carry over this portion over here and this portion over here. So we have positive 1 here and positive 4 here. So notice that this expression equals this expression. We have confirmed that the factored form of x squared plus 5x plus 4 is equal to x plus 4 times x plus 1. If the product is positive, then two integers must be either both positive or both negative. Because in order for us to get a positive product, we need to get either positive times positive, or we need to have negative times negative. And if the product is negative, then one integer is positive and the other must be negative. And this is a case where negative product equals either one negative times positive or positive times negative. We just need to have one negative and one positive. Moving on to next page. Example 2. factor x squared minus 11x plus 24. Unfortunately, this is a case where I don't want to use algebra tile because I don't want to draw 24 one bars. Okay, so you don't have to use algebra tile for every single question. Algebra tiles are there to help you visualize binomial multiplication. All right, so we'll stick to using just guess and check method. First thing we need to do is to check the coefficient in front of x squared. There's a hidden 1 there, and then we have 24 here that we need to find the factors of. Let's take a look at the factors of 24 first. We have 1 times 24, we have 2 times 12, 3 times 8, 4 times 6. All right, so it's one of these combinations, so let's guess a number. I'm gonna have to write it and erase it if it's a wrong guess. Okay, so first thing we need to do here is to write down our factor of 1. So 1 times 1 is 1. Next would be finding the factors of 24 vertically. So let's start with the first option. So let's do number 1. So we have 1 times 24. So if we cross multiply and add, we get 24 plus 1, which is 25. And also from the previous section, we talked about how this number here must be equal to this number, negative 11. But it's not, so it's a wrong guess. So number 1 won't do. Let's pick another set, number 2. So let's write it 2 times 12. Let's cross multiply and add. We get 1 times 12 is 12, plus 1 times 2 is 2, 14. Still a bit off, and so this won't do, so no to that, no to that. So let's pick a next set of numbers. We have 3 and 8. Let's cross multiply and add. So we have 1 times 8 is 8. 1 times 3 is 3. We have 11. Okay, so we're very close. The only difference is that there's a negative in the middle term. So let's take a look at how we can make this number a negative number. In a previous page, I talked about how having product of two negative numbers would give me a positive product, or having two positive numbers would give us positive product. But it looks like this positive case didn't work out, so how about let's try the negative case here. So they both have to be negative, so 3 has to be negative and 8 has to be negative. So we have negative 8 plus negative 3, which is negative 11. And this equals to the middle number. Next step is to create the brackets horizontally for the first row and then the second row. So let's rewrite this. We have variable x, and we have another variable x here. Our negative 3 will come right here, and negative 8 will come right here. So the factor of x squared minus 11x plus 24 equals x minus 3 times x minus 8. And we can double check by using a distributive property. So let's try this again. X minus 3 times x minus 8. First term with the first term with the second one. So you FOIL it, and you should get x squared minus 8x minus 3x plus 24. You get x squared minus 11x plus 24. So we got the original trinomial here. So we can confirm that this factor is indeed correct. Moving on to example 3. Factor x squared plus xy minus 12y squared. Alright, so this time let's go straight into finding factors. If you prefer, you can rewrite this as x times x instead of 1. In this case, it might be preferred because we have a different variable, y. If you want to label it, go for it, but it's not required. There's a factor of 1 is just 1. And we need to take a look at the factor of negative 12. So let's take a look at factors of negative 12. Negative 1 times 12. And the negative sign, it could be either on 12 or 1, doesn't really matter. You can try both. We have 2 times 6. We have 3 times 4 equal to 12. So let's just put the negative there for now. Alright, so let's try the first one here. So let's say I pick negative 1 and positive 12 here. If you cross multiply and add, you know that 12 minus 1 is not going to be just 1. There's a coefficient of 1 there. So that won't do. So number 1's a no. Let's take a look at number 2. 2 and 6. Okay, it's getting closer. So cross multiply and add. So we have 6xy minus 2xy. This is positive 4xy. Alright, this won't do either. Alright, there's a last option here. Let's try. Negative 3 and 4. Cross multiply, you get 4xy minus 3xy, which equals to positive 1xy. And thankfully this time we have found our middle term here. So this one's correct. So now that we confirmed the middle term is correct, we'll have a bracket around the first row here, and then the second bracket for the second row. And let's rewrite this. We have x minus 3y times x plus 4y. Let's double check by using distributive law. So this times this times this, and so on like that. We can have x squared plus 4xy minus 3xy minus 12y squared. I see a like term here, so I'm going to combine those two coefficients together. We have x squared plus xy minus 12y squared. We got the original trinomial back, so this factor must be true. So this is it for first part of 5.3.